Welcome, gentlemen. I'm going to go over the quiz that you just took yesterday or the day before, and this material is going to be on your test. In addition to this material from the quiz, you'll also have to solve quadratics by factoring, and then that's it. So I'm going to try to move through this quickly. First, our formula for the axis of symmetry is x equals negative b over 2a, where a is the coefficient of x squared and b is the coefficient of just x. So in our next question, does this parabola y equals negative 5x squared plus 20x plus 25 open up or down? Well, whatever a is tells us that. If a is positive, it opens up. If a is negative, it opens down. So this one is going to open down. All right, next question. This is a big one. We've got a graph y equals x squared plus 2x minus 3. We've got to get the axis of symmetry, the vertex, and a couple of other points. I know this is a parabola because it's x squared. I know it's going to open up because it's 1x squared. So I get right to the axis of symmetry. X equals negative b over 2a. So that's negative 2 over 2 times 1. That comes out to negative 1. So that's now the middle of my graph. I can even start to draw that right away if I like. And that might have to extend that a little bit lower. Now I'm going to make an XY chart. And negative 1 is my middle. I'll pick a couple points bigger, 0 and 1, a couple points smaller, negative 2 and negative 3. And I know this point is my middle. That's my axis of symmetry. That's going to be half of my vertex. So now it's time to plug in points, plug it into the equation. If I plug in 1, I get 1 squared plus 2 times 1 minus 3. That comes out to 0. By symmetry, I know that negative 3 would also come out to 0. I plug in 0 for x. I get negative 3. By symmetry, I know that if I plug in negative 2, I'll also get negative 3. And then finally, my most important point, I plug in negative 1. When I plug in negatives, I always put parentheses around them, so I make sure that I follow the order of operations. And this would give me 1 minus 2 minus 3, so that's a negative 4. So these are the points that I'm going to graph. Negative 3, 0, negative 2, negative 3, negative 1, negative 4. That's right on the axis of symmetry. 0, negative 3, and 1, 0. If you wanted more points, you're free to plot more points, but that's enough to see a parabola. And I want to label my axis of symmetry, so that was x equals negative 1. I want to label my vertex negative 1, negative 4. All right, moving on. I've got one of these word problems, min-max quadratic word problems. I've got a model rocket launched into the air. The formula h equals negative 16t squared plus 192t plus 4. That's going to tell me the height at any given time, where height is h and time is t. So how high is this going to be after t seconds? Or I'm sorry, after 2 seconds. T is 2. I'm just going to plug that into the equation. So h equals negative 16 times 2 squared plus 192 times 2 plus 4. 2 squared is 4 times negative 16. That's negative 64 plus 384 plus 4. I've got to do a little bit of arithmetic here. That'll be 388 minus 64. That's 324, I believe. So in 2 seconds, it'll be 324 feet high. When will it reach its maximum height? So this question, part B, isn't asking what the maximum height will be. It's when will it reach that height. It's going to happen at the axis of symmetry. Instead of x equals negative b over 2a, we're dealing with a t. So it's negative t equals negative b over 2a. B is 192. A is negative 16. Negative 192 divided by negative 32. You might need a calculator for this. That's okay. I believe this comes out to 6. So it is going to take 6 seconds before the rocket reaches its maximum height. What is that maximum height going to be? Well, just like we did for part A, we know that maximum height is at t equals 6, so I plug 6 into my equation. Again, I'll probably need a calculator to do some of this arithmetic. Negative 16 times now 36 plus 192 times 6. I'm going to just punch that into the calculator. It's 1152 plus 4. Negative 16 times 36 is negative 576. So when I sum up all of these numbers, I'm going to get 580. So the maximum height of this rocket will be 580 feet. So I found the height at just some random given time. I found out when it's going to reach its max, and I plugged that in to figure out what that maximum height will be. That's typical of all of these quadratic min-max problems. Next, I have some equations that I have to solve. And you'll notice for all 3 of them, they're just an x squared. There's no x to the first power. So I'm going to use the square root method for all of these. That means I want to isolate x squared, and then I want to take the square root of both sides. And I need to remember my plus or minus. So I'll subtract 7 from this first one. 132 minus 7 is 125. I'll divide by 5. X squared equals 25. That's nice. It's a perfect square. I'll take the square root of both sides. Radical x squared is x. Radical 25 is 5, but I have to remember my plus or minus. So x could be positive 5 or negative 5. Next equation, I'll subtract 3. I will divide by negative 1/2, which is really the same as multiplying by negative 2. And I get x squared equals 4. Okay, hey, that's lucky again, a nice perfect square. So I'll take the square root of both sides. I won't always get lucky like that. X equals plus or minus 2. And you can plug that back into your equation to check that it works. Finally, 3x squared minus 9 equals negative 9. I will add 9 to both sides. That's weird. All right, it equals 0. Let's see what happens. X squared is 0. All right, you may remember this is one of our kind of weird special cases. When I take the square root of 0, I just get 0. Plus or minus 0, there's really no sense in saying plus or minus. They're just 0. So it's one of these cases where we get one solution. I know it wasn't on this quiz, but keep in mind, if you get x squared equal some negative number, I'm just making something up, say negative 16, we stop. We can't go any further because we're not allowed to take the square root of a negative. It's just a no solution. So be on the lookout for that somewhere on the test Thursday or Friday.